Hey everyone, so we're on to the second part of the exponent laws. There's two more that we need to talk about. So in the last video, I believe we talked about three of them. So we're going to talk about two more. And after this point, now we can start getting into more complex setups. Now this video should be much shorter than the other ones since we're only focusing on two of the laws. But at this point, you'll start to notice that we're going to be combining the power rule, and the two rules that we're going to bring up, the product rule, all these things. And you'll end up having to kind of juggle all of them at once. So, one of the things that you're going to have to look out for is the order in which we tackle each one. All right, so the next law that we're going to talk about, this is like the fourth law so far, is the zero power rule. Basically, as the name implies, it's whenever this occurs whenever we have anything raised to the zero power. So here's a perfect example: 3x to the zero. Uh, this one's super easy because anything raised to the zero is 1. That's it. You can check that on a calculator. Just take a number, raise to the 0, and you'll immediately get 1 as a response. So in this case, that x is the one that's being raised to the 0, so it's the one that becomes 1, and we end up being left with an answer of 3. The one problem I sometimes see people do with this is even though this 0 is on the x, they'll accidentally put it onto 3. Remember, the only time the 0 is actually involved with all the terms is if it's outside of the parentheses. So if it's inside, it's usually marked only onto one part of the expression, and when it's outside, it's marked onto all of them. All right, so here's some practice questions, so you can pause the video, work on this out, and we'll go over in a second. All right, so we can take this step by step. Now, typically, me personally, I always like to get rid of any sort of power that is outside of parentheses. So before I even tackle this x to the 0, so I'll just carry it down, I want to actually deal with this. So as we remember from the exponent rule, when we have a variable that's raised to the power that's raised to another power outside, we're going to multiply these. So this becomes x to the sixth because that's what 2 times 3 is. Then from here, I could just say, well, x to the 0 just becomes 1. So my final answer is x to the sixth. And there we go. Easy peasy. All right, for number 2, we do the same thing. So again, one of the things that we learned with the power rule was that we distribute the 3 to all the terms and we multiply. So this becomes z, 0 times 3 is just 0, easy enough. And then 5 times 3 is 15. So once again, z to 0, this just drops out to become 1. And we're left with w to the 15th. So let me just circle my answers. All right, down to here. So once again, taking the exponents, carrying it through. Same thing with this exponent. Going to go to all 3 terms. So I'm left with negative 3 to 0. Now I'm writing this all out just so that you kind of can see all the work. Again, as I've said before, when you start getting used to a lot of this stuff, you won't have to write it all out. But in the beginning, it can be very helpful. All right. So one nice thing is because all of these don't have any exponents on them, the 4 is just going to get attached to all these and the 0 onto all of them. So once again, all of these become 1, 3 to the 0, and r to the 0. So we're left with negative 5 to the 4th, s to the 4th, t to the 4th. Now here, you could do a few things. If you want, you could plug into your calculator what 5 to the 4th is. This would be end up being 625. And then you'd have s to the 4th, t to the 4th. Another thing you could do is you could actually just leave this exponent on it. Me personally, I don't like doing that. If I have a coefficient or a constant term raised to the power, I like to try to just get rid of it. But you can leave it like that, though I probably would end up dropping the negative. So one thing that you should remember from exponents, or just about negative numbers in general, a negative number raised to an odd power like this or like this will end up giving you a negative number. But a negative number raised to an even power, like 2 or 4, will give you a positive number. That's because, as you should remember, a negative times a negative is a positive. So that means you have to have two negatives multiplied together to get a positive. And even numbers can be easily broken down into pairs of two. So uh, what I normally do is I like to get rid of that negative only because sometimes if you plug into your calculator negative 5 to the fourth, it might accidentally misread it and write it like this, negative 625, because it will think that only the 5 is raised to the 4 and not the negative. So that's one thing that I usually like to do, is just like get rid of the negative when I know it's going to end up multiplying out. But again, it's up to you. In fact, I would highly recommend that you just leave it in this way to begin with. All right. So over here, once again, the 0 is only on the r, so the r to 0 becomes 1, and my final answer is just going to be negative 3. All right, easy peasy, lemon squeezy. The zero power rule is always really nice. In fact, I know I said that I like to get rid of these 3's, but you can actually just get rid of the 0 part first. That way it's less variables for you to worry about. All right. The next law and final law, as far as the exponents goes, is the negative power law. So again, as the name implies, this is when we have anything raised to a negative power. So something like this, 3x to the negative 3. Now, this actually also pertains to anything written in the denominator, technically. As you'll see in a bit, something like this could also be affected by the negative power rule. So even though there technically is no negative power, it still pertains to this law. Again, as you'll see in a second. So the main gist of the negative power rule, the main rule is that um, whenever we have a negative exponent, we can flip the sign of that negative exponent and then move it to the other side of the fraction. So as you know, we have two sides of the fraction. We have a numerator and a denominator. The numerator is up top and the denominator is on the bottom. If we have a number in the denominator that has a negative exponent, we can flip the negative to a positive and move it up to the top into the numerator. And vice versa. If it was in the numerator with the negative exponent, we could flip it down into the denominator by making that exponent positive. I guess you can also go with the phrase that we're turning it into a reciprocal. So for example, the 3x to the negative cube that I had before, I can turn this into a positive 3, but I'd have to put the entire part, the x cube part, into the denominator now. So it becomes, to write it a little bit nicer, like this, 3x cubed. Now, one of the things I said before was that this could also be affected by the negative power rule. Now, I know in a lot of math classes, they're fine with you leaving answers in fractions. So, again, this is not something that you have to do. But me personally, I always like having no division going on. I like having basically everything in a straight line. So a lot of times what I do is I take the negative power rule, and sometimes I'll do the opposite, where if I have something in the denominator that I don't want anymore, I'll put it into the numerator by, once again, flipping the sign. So it's still part of the negative power rule, but it's kind of going the other way. Now, I think, like I said, in most of the questions that you'll see, they'll pretty much be okay and will actually want you to do this top example where they'd rather it get rid of that negative and leave it as a fraction form. But I'm just saying sometimes you might see me clean up my problems like this. Some of this has to actually deal with the fact that when I type things up in here, as you can see with how I wrote these two equations, it's not that easy for me to write it in fraction form when I'm typing it out. So sometimes I use the negative power rule in order to get it all into one single line like this, so that it's easier for me to type. All right, so we'll do some practice. Again, with these, you can leave them in their fraction form, so simplify until you get to that. But yeah, try the negative power rule. Pause the video, work on yourself, and we'll go over in a second. All right, so what we're going to do here, once again, we're going to go through all these. First, we're going to worry about the coefficients. So because there's no zero power, there's no um, any outside powers that we have to worry about, we can actually just go with what we normally do of look at the coefficients, combine them, and then look at the variables and combine them. So looking at this, we have 2 divided by 4 to the negative 3. I can rewrite that by flipping this to be a positive 3 and then moving the 4 into the numerator. So now this becomes 2 times 4 to the third. And then for this, well, this is the quotient rule. So what I'm going to do is I'm going to take the 3, subtract 12. So this becomes 3 minus 12. And then I'm going to simplify. So when I plug into my calculator, 2 times 4 to the third, I end up getting 128. When I do this, 3 minus 12, I get negative 9. So I can actually rewrite this to be 128 divided by x to the ninth. And that's it. Alright, going down to here. So there's a few things going on. What I like to do, again, I want to pretty much get rid of this negative right off the bat. So this negative gets distributed to all these terms. So it becomes 3 to the negative 1, r to the negative 3 times negative 1, and r to the 4 times negative 1. Or 3 to the negative 1 times r to the positive 3 divided by r to the negative 4th. Now from here, what I can do is I could start my negative power rule. So this becomes positive, goes to the denominator. This becomes positive, and this goes into the numerator. Now I don't have to actually do anything with this anymore because now it's positive by being multiplied by that negative 1. So this becomes r cubed times r to the 4th divided by 3. Using our multiplication rule, r to the third times r to the 4 is actually r3 plus 4 divided by 3. So in the end, we end up getting r to the 7th divided by 3 as our final answer. All right. This third problem, once again, that's what we're going to end up doing. So we're going to take all these and distribute to each of these terms. I'm not going to touch these the numbers in the denominator because it's only attached to these. So I get a to the negative 15th. Negative 5 times 3 is negative 15. B to the 2 times 3, which is 6, divided by a to the 7th, divided by b. Alright, so I'm going to flip this to a positive and then move it to the denominator. So I get b to the 6th divided by b times by 8 to the 7th times by 8 to the 15th. So using all of our rules, for the b's, I'll subtract this exponent 6 with this exponent 1. So b 6 minus 1. And then for the a's, they're being multiplied, so I'm going to add their exponents. 7 plus 15. So my final answer will end up being b to the 5th divided by a to the 22nd. And the last question is this. So I have all of this. Now, right off the bat, I can tell that h to the 4th and h to the 4th are the same. So when I do the math, so 7 divided by 21, I'll clean this up in a bit. The g to the negative 2, again, flip the sign and then move it to the denominator, will become g to the positive 2. And then this being divided will become h to the 4 minus 4th, or h to the 0, which we all know is 1. So that's always a nice thing, is if you can see two things that have the same variable and same exponent, you could just immediately cross them out, because you know when you divide it out, it's just going to give you 1. Going back to here, I can simplify this fraction a little bit. So 7 goes into 21 3 times. So this is just 1/3, and I'll tack on the g squared here. So this would be my final answer, 1 over 3g squared. All right? And that's it. That's all these rules. Now what we can do, so we've used these rules, the negative power rule, the zero rule, quotient, the multiplication, and the power rule on monomials. That's what we've been dealing with. Basically those single term polynomial expressions. Now we're actually going to bring it back to the polynomial stuff and see how these questions can now start getting more complicated when we're now adding polynomials, subtracting polynomials, multiplying, dividing, raising them different powers, and so on and so on. Alright? So just remember that these are stepping blocks to some of the other things that we'll be able to do with these polynomials. Alright, so this is the exit question. Same old, same old. Here, once again, there was a problem given for homework. Sally's working on it, and you need to help her because you want to explain every single step that she did during her solving. So explain what she did in this part, explain in this part, what was she doing, why is she doing it, things like that. Alright? So I believe this should be basically the first thing that you explain, the second, the third, the fourth, and the fifth. Alright? So put your answers in here. If you have any other questions, let me know. There are a few more questions that you can answer on those notes. You can, when you do that and you fill out those questions, they should be called the independent questions and the homework questions. Either take a picture of it, or if you edit it as a document digitally, you can submit it through Canvas in the practice questions section for this video. Alright, if you have any questions, let me know. Good luck and have a great day.